Hello, this side Utkarsh Kumar Khawla. Today I am predicting a model based on supervised machine learning. So task statement is predict the percentage of a student based on the number of study hours. And question statement is what will be predicted score if a student studies for 9.25 hours per day. So I want to bring some light on supervised learning. So in supervised learning, we train our machine learning model with labeled dataset, and there are two types of supervised learning. First is classification based, and second one is regression based. So in classification, we predict a class or discrete value, for example, male or female, true or false. And in regression, we predict a quantity or a continuous value, for example, salary, age, price. So let's come to see the data. And in the dataset, there are 25 rows and 2 columns. And I'm working on Jupyter Lab. And now see how I model this project. So uh, initially I import pandas. Pandas is a library of Python. And talking about the history of panda, the name pandas derived from the term panel data, and it also called Python data analysis. And first I import my CSV file, and I give a name student. And now the data is already in my environment. And if I want to see the number of rows and column in the data, I use dot shape command. And if I use to see the first 5 rows of the data, I use dot head command. And if I want to see the relationship between the dependent and independent variables of my dataset, I use matplotlib. And as you see, the graph shows a uh, linear relationship between the R study and percentage score. So this is a linear regression model. And now it's time to separate the dependent and independent variables. So I use ilog function, which is used to slicing the data. And uh, basically ilog is slice the data in the form of rows and columns. So as you see, the x tells about the independent variable, which is r's studied, and y tells about the dependent variable. And now we have our attributes and labels, and the next step is to slip this data into training and test sets. So here I use sklearn.model selection to to train and test and to train test split. And here you can see the test size uh, here is used 10% of my total data. And here you see the training of my algorithm. So first I split data into training and testing sets. And basically data is splitted 90% to the training data and 10% to the testing data. And this is basically a linear regression model. So as this equations defines y is equal to mx plus c, where y is that dependent variable, and x is independent variable, and m is slope, and c is intercept. And here I import a linear model. I import linear regression from sklearn.linear model. And I fit my training data of x and training data of y in this model. And here if I want to see the slope of the linear regression model. So the slope is 9.85 and intercept is 2.52. Now uh, I am making predictions of my score. So this is my predicted x test, and in y uh, and now predictions uh, continued, and this is my basically this is a um, comparison of x test and y test. And if I want to see the accuracy of the model, I use dot score, and my accuracy shows 92%, which is quite good. And this is my question statement, in which r's are 9.25. As you see, uh, the data, this is only for 7.8 hours if a student study, so his marks was 86. So I want to I already trained this model, and now uh, I'm going to check if I score 9.2, if I study 9.25 hours, how much I scored. So here you can see, if I study 9.25 hours, I got 93% or 93 marks. And if I want to check my mean absolute error, I import matrices from sklearn, and my absolute mean absolute error is 5.399. So thanks for watching this video.